Hello everyone, welcome back. Today we are going to solve question number 153 of LeetCode, which is find the minimum in a rotated sorted array. So first I will read the question, tell the approach, and then I will write the code in C++, and then I will tell the time complexity and space complexity of the question. So let's read the question. Suppose an array of length 10 sorted in ascending order is rotated between 1 and n times. For example, array nums equal to 0, 1, 2, 3, 4, 5, 6, 7 may it become 4, 5, 6, 7, 0, 1, 2 if it was rotated 4 times. As you can see, it was rotated 4 times, as first 7 came, then 6, then 5, then 4. Or if it was rotated 7 times, and again the same value would come, as all the numbers had got rotated. Given the sorted rotated array nums of unique elements, return the minimum element of this array. Now this question could have been very simple and came in easy level, but the main thing which make this question a medium level is this line. You must write the code and algorithm that runs in O of log n time. So if we are going to use a normal for loop, that could have been O of n time in the worst case scenario. But this question is asking us to write a code in O of log n time. So first of all, whenever you think O of log n time, one thing which we know is binary search. So what we can do is we will use 2 pointers to solve our question, and we will optimize the binary search code and find our minimum element. So first let's create the 2 pointer. One will be at the left, one will be at the right. So for the binary search, we know the code we run till the left is smaller than right, and we have to find the middle. For that, it's very simple: left plus right whole divided by 2. Now first we have to check which part of the array is currently sorted. For example, the middle is currently 3, so the pointer will be num of 3 is 5. So first we have to find which part is sorted. It is left part or is right part. So for that, what we will do is we will compare nums of mid with nums of right. Now if the right part is bigger than nums of mid, which means that the right part is bigger and which we don't need. So what we will do is we will make the right pointer to the middle, as that means the left part is having the minimum value. Or else what we will do is we will put the left to the mid plus 1. Now why mid plus 1? Because it guarantees that the smallest or minimum element is guaranteed not at the mid part. As you can see, if it's between 5, 1 or 2, so guarantees 5 will not be minimum. Or here as you can check, so first the pointer will be at 7 and then 2. So the pointer will come here, right will become 2, and mid will become mid plus 1, which means 0, 1, 2. Now it's guaranteed that the mid will not be minimum element. And what will we return? We will return nums of left. As you can see, all the 3 test cases have been passed. Now let's submit the answer. We got 0 millisecond runtime, which beats 100% of people. So the space complexity of this question is O of 1, as only 2 variables we have taken, and runtime complexity is of course log of n, as that's what the question was asking for us. So if you like my explanation, give a like, and for more such explanation, subscribe to my channel. Thank you.